Hello and welcome to the 8th episode of the Data Science Daily series. And I'm Anant, your host, and very excited to talk about the popular programming language, the language of choice for data science, that is the Python programming language. But there are a few things that we need to get out of the way first and understand. So let's get started. All right, what are you looking at? You're looking at a picture of a Python, right? And we are not going to pet a Python. We are going to learn the Python programming for data science, and that's going to be our focus. So why Python? Let's understand that. Why do we want to learn Python specifically? Why not pick any other programming language? It was the most in-demand programming language, and even it is still now, right? So this infographic is of 2022, where based on the LinkedIn job postings in USA and Europe, Python came out to be on the top in the US, right? And in Europe, it lagged slightly behind Java. And this infographic is attributed to coding nomads, so full attribution to them. But you can see why Python is so popular, right? It has beaten Java, JavaScript, even languages such as C++, and so on, because it's so versatile and because data science, AI, ML are really taking off, right? And a lot of people can learn Python. It's very easy to learn. Now, in terms of the community size that Python commands, the size of the programming language community is quite large for Python. And in fact, it's most popular in DS/ML, which is data science/machine learning and IoT applications. Whereas if you see the top 5 programming languages, right? The first one, JavaScript, is least popular in data science. The third one, Java, is also least popular in data science, right? The fifth one, C#, is again least popular in data science. So you can see the top programming languages, there is only Python which is standing out. And there is obviously R language, which is more for statistical learning purpose. It's not a general purpose library that you can use across the hood, right? Although R also has a very strong community base and it's not featured here, R is also a good alternative to Python. But I would recommend going ahead with Python if you're new to programming. Now that we have said that you should learn Python and you should get started with programming in Python, what exactly do we mean when we say programming? So what is programming? Firstly, let's understand what is a programming language, and then we will understand what do we mean by the term programming. Imagine a recipe, right? And that you're writing the steps down for a recipe. So you are writing the steps down for the recipe, right? You are the programmer and you're writing the steps for the computer, which is the chef, to follow, right? So let's say I want to eat a nice lasagna, right? So what I'll do is I'll write the recipe, or actually I'll just give instructions to the chef that I want it to be made in a certain way, right? So I'm the programmer and I'm writing steps. And the way I'm communicating is through a language, right? In this particular context, the instructions are written in a programming language, right? That's what we mean by a programming language. You're giving a set of instructions to the computer to execute certain tasks, and you're doing that using a programming language, because otherwise the computer will not be able to understand what you're saying, right? So you need to have a programming language. The second most common question that comes up is, what is exactly code? What do we mean by the term that you're coding, right? We use this synonymously. You're coding or you're programming, right? What do we mean by code? Now, programmers, basically people who write programs or who write code, they use code to write instructions. So the programming language is an overarching language, right? And the exact sentences or the set of instructions that you're giving to the chef, right, or to the computer in this case, is done through a code. And a code, simply put, is just a text, right? It's just a text made up of letters, numbers, and symbols, right? There is a certain syntax to it. What do we mean by syntax? Syntax is basically kind of the grammar, right? There is certain grammar for the code. But we'll dive into this much, much more later on. Finally, we come to what is a program, right? So you're writing code to give instructions to the computer, right? And a code is just a text. When we talk about a program and that you're programming, what you're doing is you're breaking down problems into steps that the computer can understand, right? You're breaking the problems that you want the computer to solve into steps that it can understand. This is like creating a program, and it's a fancy way of saying a step-by-step plan. So when you have said that you're creating a program, it's basically that you have created a recipe, right, to give to a chef, right, where you're laying the steps one by one. And programs can perform many kinds of tasks, like displaying things on a screen, making calculations, or even in advanced cases, controlling robots. So this is what programming is all about, and anyone can learn to program. It takes practice, but it's a fun and a rewarding skill to have, right? So make sure you're learning programming, and Python is for everyone to learn, right? And I will be starting Python from scratch. So make sure you're subscribed to the channel and you're liking the videos as you see fit, and also hit the bell icon so that you get notifications whenever a new session is out. Now let's switch gears and talk about what is Python exactly, right? What do we mean when we say that we are going to do Python programming? What are the key features of Python, right? So Python code is high-level code. It is easy to read. It is easy to understand from the English language perspective, right? It's not very complicated as such. It's very similar to natural language, making it beginner-friendly. Unlike languages like assembly languages, which are synonymous to very low-level programming languages. It is interpreted, right? What do we mean by interpreted? When you write the code, you can simply test and execute the code very quickly. You don't need to have a separate compilation step where you're writing code and you're compiling it then and able to run it, right? You can just write the code, run it, and test it quickly. Unlike a language like C++ that needs to be compiled to machine code before it runs. Third important feature is that it is object-oriented. Python allows you to organize code using objects, making it modular and reusable, right? So it's a very nice structured object-oriented language, right? And it can be used to create complex applications. Unlike C, which is a very basic language, but still C is not heavily focused on objects. And there are other languages as well which are not object-oriented. So this makes it quite versatile as such. And finally, it is general purpose, right? It can be used for tasks like web development, data analysis, scientific computing, and so on. Unlike SQL, for example, right? Structured query language. That's what SQL stands for. That is specifically designed to interact with relational databases. It's a very specific language. Python is very general purpose. And we'll shortly see just how much general purpose it is. Now, in Python, you have something called packages or libraries, right? Python is just a programming language, but you need to have certain concepts, right? When you're giving a recipe to a chef, there are certain concepts that the chef needs to understand, right? So what Python packages are, they are like concepts, and they are specific concepts for specific tasks, right? We'll shortly see what exactly different tasks do each libraries focus on and enable us to do using Python, right? So Python is a language, but the packages themselves enable us to perform specific tasks. And we'll shortly see how. Packages are basically Python programs only, right? So that's what they are beneath the hood. It's just a giant matrix of programs, right? Call it a package, call it a distribution, everything. If you distill it down, it's just a code, right? Think of it like the matrix. Now, what is a package? Formally, packages are Python programs, and they make coding easier. Python has a vast ecosystem of pre-written code called packages, right? There are pre-written code, and then there are packages that developers can also develop, right? So I am a developer, for example. I can develop code and put it on PyPI, which is the Python package index for anyone to use, right? Because Python is an open source ecosystem. What is PyPI? Right? PyPI stands for Python package index, right? And we also shortly call it pip, because to install different libraries or packages, you simply say pip install, and then you name the package and you run it, right? So it's a very, very common, very, very powerful Python package management system. So you can use a tool like pip to search for and install packages, giving you access to powerful functionality without writing everything from scratch, right? Calculator, you don't need to write it from scratch. Advanced language modeling, you don't need to write it from scratch, right? Machine learning packages like regression, you don't need to write a regression model from scratch. You have packages available to help you implement regression. They have already written the low-level code for you. So this is what we mean by a package. And pip or Python package index is a very, very common, powerful way to install packages. Most of the Python packages are available on pip. Now let's understand and talk about some basic Python libraries for data science. Right? Where do you get started? Firstly, you need to get started understanding the fundamentals of the Python programming that we will cover in the next few videos. But this is to give you a sense of the Python libraries also that you should be aware of if you are an aspiring data scientist. And these are the basic libraries that every data scientist should be aware of. NumPy is the first one. It stands for numeric Python, right? It helps you do numerical analysis or numerical computing. Basically, you're doing matrix multiplication, you're doing different kinds of analysis, all using numbers, right? So it's a very kind of a low-level library, basic library on top of which other libraries get built. So it's NumPy. The second one is SciPy, right? Scientific Python. That's what SciPy stands for. And it is having a lot of scientific computing functionalities within it, right? So just after NumPy, it's always a good idea to learn SciPy. You can do signal processing, for example, using SciPy and other scientific analysis as well. Then we come to the Python library for data analysis, right? And that is Pandas library. Now, this is a library which helps you analyze data, right? You're not dealing with matrices anymore. You're not dealing with numbers directly as arrays. You're dealing with large structured CSV files, for example, and all those could be handled by Pandas. There is a more efficient implementation of Pandas called Polars, but Pandas is the most widely used library out there for data analysis, for data science, right? So this is one library that you cannot afford to miss learning, right? You can afford, I would say, you can afford, if you don't have enough time, for example, you can afford to miss NumPy, SciPy, but you cannot afford to miss Pandas. Without that, you will not be able to do data science. Stats model is the next library that you should learn, right? Once you have done basic data analysis, stats models allows you to implement statistical tests, right? Implement hypothesis testing, everything statistics, stats models is there for you. Once you've done this basic analysis, remember in the data science development process, we come to the EDA phase or the exploratory data analysis phase. And that's what we are going to do now using Matplotlib, right? It's a basic library visualization. It's the fundamental library for everything visualization that you should know about, definitely know about. This is another library you cannot afford to miss. Seaborn is having much more visually appealing visualizations than Matplotlib. It has more powerful visualizations as well, right? So after Matplotlib, it's always a good idea to learn Seaborn at least. Know two libraries for data visualization, right? Always learn Seaborn as well. And then there is another library which is also very popular and often used for interactive visualizations where you can see the dots when you're hovering over the particular plot. That's Plotly, right? It's very nice for interactive visualizations. And it's also a very nice library in general. So you can make a choice of what all libraries you want to learn. Actually, once you start learning libraries, once you start getting proficient with Python, it's very easy to pick up new libraries, right? It's always the first few libraries that you're learning, how you're learning to code in general, that helps you get better at learning, right? Learning how to learn. And finally, we come to machine learning library, the core library for everything machine learning, right? I'm not saying this is the library that implements everything in machine learning. I'm saying this is the one-stop library that is the single most important library if you want to implement machine learning, right? There are other libraries that do a lot of other things, but this is the one you cannot miss if you are going to be a machine learning engineer. That is Scikit-learn. All right. These are the general libraries for data science. Now let's go into some specific libraries, right? Before that, actually, I want to introduce the Anaconda distribution. And this is kind of a meta package manager, right? It's named Anaconda, right? Sound familiar to Python? Both are snakes, right? And Anaconda is a much bigger snake than Python. So this is a very nice blog on what's in the name, clarifying the Anaconda meta package. And this is a meta package that helps you install NumPy, Pandas, all of the regular packages of data science, like SciPy and so on. So it's very easy, and you can see that it includes Pandas, Scikit-learn, multiple data visualization options, and so on. And it's a very, very good starting point for learning data science and for installing all of these different packages, right? It takes care of the dependencies as well. All right. Other important Python libraries that you should know once you have learned the basic libraries and you want to get one notch further. So I will just show you how vast the Python language is and how different applications it can actually handle. Application focused libraries. This is library called Pyro, which is for probabilistic modeling, right? And this library has been developed by Uber. Very good for probabilistic modeling. DoWhy library. This is very popular library for, this is a very nice library for causal inference, right? If you want to understand the why in the data, this is the library that will enable you to do causal inference, which is really a very, very specific statistical task that needs to be done. Nixtla, it is an open source Python ecosystem for time series forecasting, right? And it is a very, very powerful implementation. It's very efficient and it has a lot of different algorithms. So if you are doing anything related to time series forecasting, I would suggest go ahead with Nixtla. Yellowbrick is a library for machine learning visualization, and there are a lot of different visualizations that you can make use of with this library. It enables you to do, for example, residual diagnostics, right? It enables you to build all those kind of diagnostic plots very easily. That's just an example. There are many more. LangChain, right? 1 year back, when LLMs started booming, LangChain also started booming, right? Because this is the framework where you can actually build large language model based applications, right? This is a very powerful library that you should learn if you are going to do anything related to generative AI for language particularly, right? LangChain is a very, very powerful library. Gurobi, this is mainly a framework, very old framework and very powerful solver, as we call it, for optimization, right? Gurobi is a very powerful solver, and it's, we can call it a library as well. And then there is another library for optimization that's called PuLP. So both of Gurobi and PuLP are optimization-based libraries, right? Libraries that enable us to write constraints, formulate, the objective, and solve for the optimal values of the decision variables. Let's see some more, right? Django, which is a powerful backend library in Python. You can create backend applications, right? If you're a software developer, you will probably be aware that Django is a very nice framework to learn, right? Selenium, it's a web browser automation framework where you can, web scrape easily. So Selenium along with Python, you can web scrape data very quickly. And once you have web scraped it, you will need to parse that HTML or XML tags. And BeautifulSoup is a very nice text parsing library, right? Mostly these libraries, like BeautifulSoup, for example, is done for natural language processing, where you're scraping language data from the internet and you are basically processing that and you're trying to understand what's there in the data. HuggingFace. HuggingFace has all of the latest, transformer models, the GPU models, everything is hosted on HuggingFace, and there's many more applications, right? You can do sentiment analysis, you can do different things with HuggingFace. So it's a very nice framework to learn as well for natural language processing specifically. Gensim, it's a library for topic modeling, right? Again, it can help you do text pre-processing, remove stop words, stemming, lemmatization, etc. Don't worry about these words and these terms, but just know that it's a very powerful library for natural language processing. PyTorch, it's a library developed by Facebook for deep learning, right? Again, a very powerful, very popular library, very easy to learn if you're looking to start in deep learning. Compared to TensorFlow, obviously, is the industry favorite, right? And this was developed by Google. It is the industry favorite for most of the deep learning deployments. However, there's a steep learning curve. So if you're starting in deep learning, I would personally recommend learning PyTorch first. OpenCV, it's a library specifically for computer vision, right? And again, an indispensable library if you are doing anything related to computer vision. You will need to do a lot of pre-processing and processing for images. OpenCV will allow you to be very flexible doing everything computer vision. And there are many more libraries. So you can see just how vast different applications can be handled by Python. And why Python is such a powerful framework to learn, a powerful library to learn, just because it enables all of these things and many more. All of these use cases using all of these libraries can be implemented in Python. And I have not even listed other libraries that I know of, right? So it's a very, very vast ecosystem. It's very rapidly developing. For example, LangChain just became popular about 1.5 years back. And there is a large open source ecosystem where developers are developing new packages and rolling them out, right? For the same task, right? For deep learning, you have multiple packages. You have Theano, right? And many more, right? Similarly, for other machine learning based tasks, you have a lot of other libraries. Like for time series, you have PyFlux. For survival analysis, you have PySurvival, and so on and so forth. So this is all about motivating you to learn Python, why Python is important to learn, and what exactly is Python. We saw a few features of Python as well, right? Don't worry if you didn't understand all the features, right? That's not as important as trying to actually get hands-on, learn Python, implement something, and just do it like you're learning an instrument, right? Like just learn it. Don't worry about the theory behind it as much. And that's going to be our focus, practical Python starting tomorrow. So tomorrow we will start with installing Python and then get started with the basics. So I will see you tomorrow. That's all for today. As always, if you have any questions, feel free to put the chat. I will get back to you as soon as I can. Thank you. Stay tuned. See you tomorrow.